Ever stop to think about what's actually running the device you're watching this on right now? Well, chances are it's a direct descendant of a technology from the 1970s called UNIX. And it's one of the most important innovations in the history of computing.
And that's really the perfect way to think about it. Instead of some dusty old relic, think of Unix as an ancestor. It is quite literally the grandparent of our modern operating systems. It laid down the genetic code for pretty much all the tech we use every single day.
And I am not exaggerating at all. Your PlayStation 5, your iPhone, your Android phone, even that little box humming away in the corner, your home router. Yep, their DNA, their fundamental blueprint, traces right back to the core ideas cooked up for Unix.
So how did this all start? Well, like a lot of great inventions, it actually began as a failure. We have to go back to the 1960s, a time when computers were these giant, room-sized machines. So there was this massive, super ambitious project called Multics that was just falling apart. But one of the developers on it, a guy named Ken Thompson, he saw potential in the ashes. By 1970, he and his team at Bell Labs, which included the legendary Dennis Ritchie, had built a much simpler, more stripped-down system. They called it UNIX, spelled with a CS, kind of as a joke, like it was a neutered version of Multics. But the real game changer, the moment everything shifted, came in 1973. That's when Dennis Ritchie rewrote their entire operating system in a brand new programming language he had just invented for this exact purpose, the C language.
So why was that such a huge deal? Well, before C, operating systems were basically welded to the specific hardware they were built for. Rewriting Unix in C made it portable. All of a sudden, it could be adapted to run on a huge variety of different computers from different manufacturers. This one decision let the genie out of the bottle. And once it was out, there was no putting it back.
Okay, so we've got the origin story. But what is Unix, really? What makes it tick? Well, it all boils down to this incredibly simple, yet ridiculously powerful core philosophy.
This right here, this is the soul of Unix. Instead of building one gigantic, complicated program that tries to do everything, the idea was to create lots of small, simple programs that each do one thing and do it really, really well. You can then chain these tools together to do incredibly complex things. It's like having a toolbox full of perfect, single-purpose tools instead of one of those clunky multi-tools. It's brilliant.
At the absolute core of this system is the kernel. Think of it as the brain or the heart. It's the central program that has total control over everything. It manages the computer's memory, it decides which programs get to run and when, and it handles all the communication between your software and the physical hardware. It's the boss. So if the kernel is the brain, how do you talk to it? Well, that's where the shell comes in. The shell is that command line interface you see in the movies. When you type a command, you're not talking directly to the kernel. You're talking to the shell. And the shell acts as your personal interpreter, translating what you want into instructions the kernel can actually understand and carry out. And this lays out the whole structure perfectly. At the very bottom, you've got the physical hardware, the machine itself. Sitting right on top of that is the kernel, controlling everything. The shell provides that next layer up, letting us users interact with the kernel. And then finally, on the very top layer, that's where we live, with all the applications and programs that we actually run.
Okay, this brings us to one of the biggest points of confusion in all of tech. You've heard of Unix, and you've definitely heard of Linux. They sound alike, they're clearly related, but, and this is important, they are not the same thing.
And here's a fantastic little fun fact that clears it all up instantly. A core component of the Linux operating system is a project called GNU. And what does GNU stand for? It's what's called a recursive acronym. It stands for GNU's Not Unix. They literally built the distinction right into the name.
So let's just break it down side by side. Unix was born in the 60s at AT&T Bell Labs, and its source code was proprietary, meaning AT&T owned it and you couldn't just get it for free. Linux, on the other hand, was created way later, in 1991, by Linus Torvalds, and it was open source from day one. That meant anyone could see the code, change it, do whatever they wanted with it. And while the original Unix was often tied to specific, expensive hardware, Linux was built to run on pretty much anything. So think of Linux as a clone, a spiritual successor. It's UNIX-like, but it is not technically Unix. So now that we've got that cleared up, let's zoom back out and look at the massive, sprawling legacy of Unix. We're going to trace the family tree that literally built the digital world we all live in. Because Unix didn't stay as just one thing for very long. Its power and its portability meant that universities and companies all over the globe started adopting it and tweaking it for their own needs.
This caused the original to branch out into this huge, complicated family tree of different versions and flavors.
And you can really see three main branches here. First, there's the BSD branch, which started out at UC Berkeley. This branch eventually led to something called NextStep, which then became the foundation for, wait for it, Apple's macOS. So yeah, every Mac is a direct descendant of Unix. Then you have the System V branch, which led to big corporate systems. And of course, you have the UNIX-like cousin, Linux, which today powers Android, most of the internet servers, and so much more.
So what about the other giant in the room? Where does Windows fit in? Well, it doesn't. Windows is the exception. It comes from a completely different family tree. It grew out of an earlier operating system called MS-DOS, and its entire architecture is fundamentally different. So while it was definitely inspired by the world Unix created, Windows is not, and never has been, Unix-like.
And you know, its influence goes even beyond our operating systems, because Unix was so powerful and flexible, it became the default creative sandbox for programmers in the 80s and 90s. The very foundations of the internet, the servers, the tools, the protocols, they were almost all built by people working on Unix systems.
And that kind of brings us to a final thought. That core philosophy of Unix, modularity, simplicity, using small, focused tools to build powerful, complex systems, well, in our modern world, where software is becoming almost unimaginably complex, you really have to wonder, is that elegant 50-year-old lesson more important and more relevant today than it has ever been?